This is the Hazel Park Amateur Radio Club weekly progress report on the ARDC, the Amateur Radio Digital Grant. So I think we pretty much have cleared away the antenna and the components that need to be ordered and in process if it's not already complete, but it's in process. So now the next big step here is to figure out the equipment. So what we're doing in that regard is what are we building? Like, number one, what is the system that we're trying to put together here before we even start talking about the repeater, which we'll talk about in a minute here. But before we do, I just wanted to sketch this out roughly, and then we'll proceed with this template as to what we're building, because that'll make a big difference on what repeaters we purchase, what repeater controllers we purchase. So here we have our VHF site 146.640, okay, and our UHF site. Now the idea is at the UHF site, as you know right now, we have the Fusion, we have the Yaesu Fusion or analog, and it's selectable. Whatever you transmit, it will either retransmit Fusion or retransmit analog. Then at the VHF site, currently we have the Quantar, which is analog FM. Now analog FM is the only mode, so in an emergency type situation, having an analog radio is a big plus. And it's a big lesson learned on 9/11 when the police department couldn't talk to the fire department, couldn't talk to the mayor's department. So that's one of the big advantages of analog, is that it is interoperable with most handsets made today. The VHF site has internet connectivity, terrestrial internet connectivity. Then the other idea was to set up this digital link, which we purchased, to communicate, to link together the VHF and the UHF system. And in all of that, on the UHF side, then we have Fusion and analog FM. Then in the future, we could have Starlink connectivity to satellite internet, so that we're totally not terrestrial. We're totally off the grid. Now, the one thing we have to think about, encryption, as we know, is not allowed in amateur radio. And so when the internet is mixed into an amateur radio link, that consideration has to be taken, and we have to figure out what the policy is on all that. So that is just kind of an idea. Now, along with that, when we look at the Motorola SLR8000, which is the Motorola repeater that pretty much replaces the Quantar, there's five different configurations that it can take. So it looks something like this.
Let's start at the simplest level, the single-site conventional system. One repeater, one location. Perfect for a hotel where you need strong coverage from the basement all the way to the penthouse. Now let's step up. IP Site Connect links repeaters together over the internet, extending coverage across a wide area. It's what a school district might use to connect several campuses seamlessly. Moving up again, we reach Capacity Plus. This is entry-level trunking, where multiple repeaters share the load for voice and data. It's well suited for hospitals with many buildings and busy staff. Next, there's Capacity Max, Motorola's advanced trunking platform. It handles more users, more sites, and gives better roaming and system diagnostics. A strong choice for logistics and transportation fleets. And finally, the top tier, Connect Plus, a proven high-capacity system widely used in public safety and large commercial operations. It keeps users connected even across overlapping sites and vast coverage areas.
As you can see, this is a serious repeater with some serious capabilities. So the question is, which one of these configurations works best for us? This configuration here, the two-site configuration works for us, and it does. They're connected by the internet, but we're going to have this link. So this icon here represents the microwave link between the VHF and the UHF site. So this is 5 different configurations that it can take. So I just want to go through real quick so that folks can understand that what these sites are. So it looks something like this. Now, I have an audio track attached to this, so I hope the level is correct. If not, do let me know and I can make the adjustments. So turn up your speakers there and just take a listen to this. It's about I don't know, a minute 30, 2-minute explanation of what this is, and we'll talk about which configuration is right for us.
Let's start at the simplest level, the single-site conventional system. One repeater, one location. Perfect for a hotel where you need strong coverage from the basement all the way to the penthouse. Now let's step up. IP Site Connect links repeaters together over the internet, extending coverage across a wide area. It's what a school district might use to connect several campuses seamlessly. Moving up again, we reach Capacity Plus. This is entry-level trunking, where multiple repeaters share the load for voice and data. It's well suited for hospitals with many buildings and busy staff. Next, there's Capacity Max, Motorola's advanced trunking platform. It handles more users, more sites, and gives better roaming and system diagnostics. A strong choice for logistics and transportation fleets. And finally, the top tier, Connect Plus, a proven high-capacity system widely used in public safety and large commercial operations. It keeps users connected even across overlapping sites and vast coverage areas.
Okay, so as you can see, this is a serious repeater with some serious capabilities. So the question is, which one of these configurations works best for us? Now, looking at this, initially thought that this configuration here, the two-site configuration works for us, and it does. They're connected by the internet, but we're going to have this link. So this icon here represents the microwave link between the VHF and the UHF site. So this is a configuration that could work for us. Certainly the single site could work for us, but seeing as we have the two sites, let's take advantage of the capabilities of doing what we can with them. Not only one site is VHF, one site is UHF. The UHF site is fusion, right? And the VHF site, for the most part now, is analog FM, okay? Now, if we do go ahead with this Motorola, the SLR 8000, then it gives us more selectivity or more choices, basically, where the VHF site could be a DMR, for example. Well, here's an example here, let's say. One site can be DMR, one site can be fusion, and both sites can be analog because they're both analog capable and switch automatically depending on what the received signal is. Okay, and again, here you have the internet connectivity, and then here you have the microwave connectivity, the All-Star network. Okay, so something else that we might want to take advantage of. But just so take a listen. And
All-Star Link is an open source technology that extends the reach of amateur radio repeaters. It works by connecting repeaters and nodes together over the internet using software originally designed for the Asterisk phone system. Each node is tied to a local radio or repeater, and when a signal comes in, the audio is digitized and carried across the network to other linked sites. On the far end, it's retransmitted back over RF, so a handheld radio in Michigan could be heard instantly in California. What makes All-Star Link especially powerful is its flexibility. It supports simple linking, wide area coverage, and even advanced features like voting, where the system automatically selects the strongest signal. For the Hazel Park Amateur Radio Club and our DART repeater, this means stronger reliability, greater coverage, and a true connection to the worldwide ham community.
Okay, so here's a new variable that we're adding into this, and that's the All-Star link. And the thing that attracts me about it is because it has the capability for voting. So we want to take a look at that and learn a little bit more So we're going to look more into what All-Star has to what All-Star has to offer, and we'll have a little bit more to talk about. Those are the topologies that we have to consider here. Take a look at that in more detail and have more to report on that next week. Let's talk about the Motorola SLR 8000. In the original proposal, there was the 5700, the SLR 5700. So looking into that, well, it's discontinued, and the current model can operate either analog, right, or analog digital repeater. Power output's 100 watts, so that's continuous. That's good FM and data. And it has a very sensitive receiver, an input of 0.3 of a microvolt. So when you think about how high we are up and the capability of this radio and the gain of our antennas, we did a little calculation here. So figure a handheld 10 to 15 miles away would be able to communicate with the repeater. Mobiles would be up to 30 miles, and a base station, you know, with a decent antenna, it could be up to 40 miles away. So that's interesting to think about. Connection between the two, comparing the two. Let's listen to this for a minute.
This chart compares what the modern Motorola SLR 8000 does better and where the older Quantar still holds its ground. The SLR 8000 offers a compact rack-sized design with improved filtering, lower noise floors, and solid 100-watt continuous duty performance, all with modern cooling and diagnostics. It's built for today's digital world, supporting Mototurbo systems, remote management, and efficient power use. On the other side, the Quantar still deserves respect. It delivered excellent sensitivity, continuous duty models, and rugged analog service. Many Quantars were even upgraded to handle digital modes like P25, but being older, they require more maintenance, have less efficient digital performance, and parts can be harder to find. In short, the SLR 8000 is the right fit for new deployments, while the Quantar remains serviceable where reliability and cost are the main concern.
So that's a comparison, and that's what this chart here shows. You can a good guide as to which direction we should go in there. Here's the technical specifications. It can do VHF or UHF, of course, depending on how it's set up. And it's right within our specification. RF output power. By the way, we measured the output power of the Dart. Sean was with us. This is a couple of years ago, but things are pretty much the same. So which looks something like this. We're getting about 85 watts out of that radio, if you look very carefully. So here we have 80, 85. So we're getting 85 watts. This is the meter, and this side is feeding the antenna itself. On the side on the left there, that's coming from the output of the duplexer. So it's a good bet here that 80, 85 watts, something like that. So this was just to show that, but that's actually where the white dot is, and it was on the 150. See the 150 scale there? So we're there. We're between, well, let's say we'll call it 82.5 watts. Then the other thing to consider, which this repeater also has, is the AMB2 encoder, and this is the device, of course, that takes our analog world and turns it into the digital world. The chips that do this AMB plus 2, it's using D-Star and DMR and Fusion, you know, all the popular amateur radios. All right, so that's the repeater. So after looking into it quite extensively over the last week or so, I would say that it would work very nicely for us. And in addition, it has all the remote access for remote monitoring and servicing and things of that sort. So a good deal, and I think we should move ahead and make the arrangements, and we can purchase that. The next thing I want to talk about is radio frequencies. And so when we look at the radio frequencies that we operate on, that we're looking at something like this. So On the left side is the VHF neighborhood, and then this is our band, the VHF band, from 144 to 148. Okay. On the right side, we have the UHF neighborhood. Now, what's interesting about this is the amateur band, 420 to 450. So I drew this to scale, I might add. This is the VHF bandwidth, if you want to use that as a comparison. So there's 5 times the amount of bandwidth in the UHF amateur band than there is in the VHF band. Just get a sense of what we're talking about there. So that's why in the UHF band, that's why there's plenty of room for our auxiliary links between the remote sites. And this is what we use for the calculations for the area to figure out what the likely reach is going to be. And if you look at this map, and this map has been around for a very long time, but this has the footprint of the dart going out, I don't know, maybe about 15 miles at the peak. Here it's 18 miles over here. So I'd say maybe a good 15 miles diameter. Okay, so there seems to be a discrepancy between this map, and again, I'm not sure exactly what the parameters were to create this map, but it's the only really footprint map that we have of the dart. But as I'm comparing it to what the calculations came out here, it is quite a bit difference. And so we may see, once we replace the antenna and the repeater itself, we might see a difference here. Let's hope so. So that's what we're looking at.
I would definitely like to see a increase in coverage in the northwest quadrant of Oakland County. Big open spot that we're really lacking coverage in.
We sure are, right up in there. So that's a good point. So we can focus on that.
That would increase our usefulness to ARPSC also.
Yeah, all this here. So we'll take a look at that. We'll see how we can improve it, because if there was a way really to direct all the energy that's going out over the lakes, use some sort of a directed array, that would be one way of doing it.
That would have been the advantage of a folded dipole over an omnidirectional.
The folded dipole in the configuration that we were looking at was circular, because we had one in each quadrant, going around every 90 degrees. So I'm not sure, but for sure, folded dipoles can be made in an array that's directional. What we're looking at, and again, it would be ideal if we could take a few measurements before we do the work, and then of course take measurements after to make sure that we're at least meeting our performance that we previously had, and hopefully we're doing better. But we will focus on the upper left-hand corner, the northwest corner of Oakland County. I go on the internet and say, all right, how much is this repeater? If you go to eBay, it's only $2,000, but then you can go to Alibaba and pay $15,000, your choice, or anything in between. So you can see.
Yeah, Joe, I sent you a couple links last week, email list for the dart. But yeah, it was about the SLR 800, and there's 2 or 3 different retailers. They had them on sale right now. But yeah, I was recommending the 8000 over any of the other Motorola's. This thing has a lot more capabilities, and we'll be able to branch out and expand as needed, and use every function. Now, the MB2 vocoders, I don't know if it comes with all of them for all the different codes. They might have a separate price tag to them. I'm not sure how many bays you can put, how many different vocoders in there. So that's something we're going to have to look at, or someone should, how much the vocoders are per mode. But yeah, it was a couple of sites, and they had, a few ranges of prices for it. And a lot of them, I think a couple of them had them actually in stock too.
Yeah.
I don't know. It was a response to the club, the DART meeting from last week.
So I'm glad we're in agreement with that. And is with the cost. I mean, if you figure this radio, you got to figure it's going to be about $8,000 is what I can see, and maybe less, but figure $8,000 just for now. So we may have to rearrange our allocation. A good quality SLR 8000 that's outfitted with the options that we would like to have on it. So, but here's where we are right now. And again, the antenna, we're pretty much done with the antennas, and the IP networking is also in progress, is being made there. I know Dave Tony's been working on that. Yeah, yeah. And so there you are. All right, now here so here's the possibility. Now this place here from North Georgia Communications, okay, and this is why I say the 8,000 mark is probably reasonable. Here they have contact us for discount pricing on, well, certainly not volume, but on amateur radio. So perhaps we could get a bit of a break, although this alone is right within our reasonable budget.
I just resent that email.
Oh,
Joe.
let me see.
Yeah, there you go. Two-way radio. That was the other one. They had it for around $5,300.
Yes, right. 5,300
Yeah.
right there. Exactly.
Yeah.
Oh, is that okay? All right. So another, again, going through these websites, they look like companies that are on the up and up and something we should think about. So here are two good sites. Then there's two more. There's Bearcom in White Lake, Michigan, ComUSA in Rochester Hills. So those are the two local companies. So we have vendors here, and I would like very much get 3 quotations. We could move ahead. Finally, the last thing I have for tonight, I just want to talk a little bit. We purchased the Telwave duplexers, so I just want to point something out about that. So this will be coming in soon, and these are the specifications and all that. Here's what I came across. I just thought was interesting. It was Sean, and I know John, A8UU, and I'm trying to think who else was up there. It seems there was 2 or 3 other people. So we did this testing, and Sean had his tracking spectrum analyzed. Anyway, so we took these measurements here. So here's something kind of interesting. So if you look here at marker 1, right? So marker 1 is 146.040 right here, okay, or thereabouts, close enough. 146.040. So this is the listening frequency that the DART is on. And then the transmitting frequency, 146.640, is here, right, marker 2. And then the true null of the current diplexer is actually here. So there's, a 3 or 4 dB difference between the two. Now, I wouldn't be too worried about it. The half power point is 3 dB because the transmitter is going on. This may be one reason why we're only measuring 80 watts out of a 100 watt transmitter. We're only getting 80 watts at the output of the duplexer. That could be one reason. When our new duplexer comes in, we'll run a very similar test, and we'll make sure that it's been tuned properly, because both of these markers should be right down here in the valley, and so that's what we're looking for. So I just wanted to point that out there. Here's a close-up so you can see the difference. So we'll keep an eye on that. So I don't know what the delivery date is, but it should be arriving at some point soon. And that's really what I wanted to talk about. If we could formalize our game plan here, meaning the big picture, I will draw it up so that we can take a look at it. But this is the system we're building. The next big topic for next week, and I'm trying to get Phil Ross to join us to talk about controllers. Also, we'll have more information by next week is, do we need an external controller like we currently have today, or could we use this All-Star node as a voter? I didn't mean a controller, I meant voter. Do we use the All-Star node? So we need some more information as to what the reasonable expectations are if we use All-Star. One of the things that bothers me a little bit is it's off-site. So if we lose communications, does that mean that are we still functional? So we'll get a reading on that as well. But that's pretty much it. That's what I have for now. Does anybody have a question or a topic that they want to talk about, or a question they want to ask?
Well, this is the first drawing that I understand.
Well,
I like it.
in 5 years, we'll post it on the wall next to the repeater. This is what started it all. But yeah, I mean, it's pretty simple. It gives us access. I like being plugged into the Starlink network, the IP satellite network. Of course, there would be some latency issues involved. Although I've been hearing a lot about the way that our VHF and UHF repeaters are connected now. There's often people are noticing there's a latency between the two, and that's correct, because it for different reasons the signal gets demodulated and it's back down to baseband audio, then remodulated, all that kind of stuff. So yeah, there is latency. When we set up this system, the latency will be not noticeable. So the two repeaters will pretty much be transmitting in sync with each other. It'll be interesting to see if we can get.
Only way you notice that, Joe, is if you have both of them on at the same time. You really do that. From what I've heard and seen, you have to have the UHF and the VHF on at the same time, one in one ear, one in the other ear, to hear the echo, to hear the latency. A normal way of operating.
You can't have a crossband QSO with the way they're set up right now because of the latency. There's not enough, most of the people out here don't leave enough of a pause in between letting the repeater drop or identify or, unkey before they retransmit, or, they call it quick keying. So when you're trying to have a crossband QSO between the UHF and the VHF, the latency makes it nearly impossible unless everybody lets the repeater reset between the two. So you got to at least let 3 seconds go by. Otherwise, the other band, the other repeater, is clipping off the beginning of whatever the person is in transmission. So you'll miss the first 3 or 4 words if you don't key it up, wait a couple of seconds, and then transmit. It's the latency issue. Yes, and unless you have both of them on at the same time, you won't know it. And if you're trying to have a QSO with somebody, and you don't leave enough of a pause or a gap, or a pause before transmitting, they won't hear your whole transmission. So that's the problem with it right now.
Looking at this example, just for, like let's say the UHF is DMR, let's say the VHF is Fusion. If you wanted to talk to somebody, you had a Fusion mobile in your car, and you wanted to talk to somebody who had a DMR handset, what you're saying is that although on paper it looks very clever here that we could connect them together and they can work as one, what you're saying is that these latency issues need to be addressed. And
that won't be an issue if you're going to use either All-Star or one of the modes on the Motorola itself. You won't be using Echolink in the process. So I guess you're still not clear how the two repeaters are communicating to each other. Is that correct?
Right, that is correct. And yes, we have to learn more about that. Yeah.
Right.
Right.
There's Echolink being used on both the input and the output of both repeaters through John's house back to the other repeater. So it's a triangulation. And that in itself is causing the latency issue. So if you want to have a QSO from the VHF to the UHF side, you have to make sure you leave enough pause in between transmissions or when you start to talk, because there's a 2.5 second latency delay that occurs when you're triangulating a signal like that, cross-banding over Echolink, over RF. That's the craziest thing about it, is he's retransmitting the input frequency for VHF to the input frequency on UHF, and vice versa. So it works, but it's not efficient to hold the QSO. Now, if you're just going to make a transmission, fine, half of it's going to be cut off on the other frequency.
Would take that into mind, yeah.
I agree. I think if we're going to do it right, get the 8000.
Yeah.
It has all the transcoding capabilities I think the DART or HPARC will ever need, and you can always add more on top of it with your MB2 vocoders. So that's the
Yeah.
other thing we're going to have to figure out, is there an incurred cost with different modes, different uh, vocoder modes, different transing or transcoding now, right? You're going to go from fusion into DMR or from fusion into D-star, right? So you're transcoding digital signals to digital modes. So, right, we don't have that right now. Right now, you're connecting a VHF repeater to a UHF repeater via Echolink and transmitting the input frequencies of each repeater to the input frequency of the other repeater. So if you listen to the input frequency on the UHF and someone's transmitting on the VHF, it's the exact same signal. You're hearing the VHF transmission on UHF input. And same thing on the input for the VHF, because the way John has it set up right now is triangulating back from his house via Echolink over RF.
Yeah.
But it's not efficient. It's causing a great lag, and it's nearly impossible to have a true cross-band QSO, because that's exactly right now these two repeaters they're cross-banding. If you had a HT and you wanted to cross-band it from your base station onto either a simplex or a repeater, you're cross-banding one band to the other. But because of the way it's being done, there's a latency problem. So you're not getting the whole QSO, and people are dropping out. Other people may check in on UHF to like LensNet last night. I think it was Jay or somebody was trying to check in on UHF, and there wasn't enough gap left because of the 3-second latency. There wasn't 3 seconds given on VHF to let the UHF signal interfere or interject, we'll say.
Right. What we're currently doing is, so you're receiving an RF signal. That RF signal is then demodulated. That demodulated signal is then decoded. It turns into audio. Then the audio goes into the transmitting side. Then that audio gets re-encoded, which gets remodulated, which gets retransmitted. It's what the latency is about. So in the satellite world, what they do is they don't demodulate the RF. In other words, they'll take the RF directly out of the receiver or the front end and send that same RF signal to the transmitter, so that you bypass all those stages which are unnecessary. And that's one way that they're able to cut down on the latency in that situation. And I'm wondering, now that you bring that up, I'm wondering, as we learn more and more about the 8000, questions like these we'll be able to answer.
Well, I think it's actually unique and actually probably beneficial that you found 2 local distributors. And I think that would be a good start, is to contact the local ones. Hey, turnkey, let's keep it local if we can, support local business and let them do all the heavy lifting that we know nothing about, or to provide us with a proper, education and direction to set up. But if you're dealing with somebody local that has a local address, hell, they can come in and install it too, perhaps, right? Set it all up. So I don't think, at this stage of the game, with what we got and how much we have, we want to get the best equipment. We need to do it right the first time, provide proper, an avenue for us to learn on, or a direction, basically, a mentor,
Yeah, support.
And
So I think definitely call those 2 local places and, get a quote from them. Hell, I think that would be ideal to have someone local. They could even have a seminar. Maybe they could come to Len's house and all of us can come over and watch them set it up, so we know how to tear it down and set up when we move it.
okay, point well taken. Yeah, I agree. Local is good. Shop local. All right.
Also convenient. Sean just lives across the equipment from me too, so he's be a good resource for us.
Excellent. In fact, I have to give credit to Sean. A lot of this had to do with a lot of his feedback on this as well. So, yeah, we're lucky. Just generally speaking, we're lucky to have a guy like Sean. So, but definitely we'll get some quotes. We'll get that moving, because we want to get this equipment in-house, get everything purchased, and then we'll focus on putting it together. But now that we have our game plan And by game plan, I mean like the big picture here. It gives us, it keeps us focused. So we'll have a newer version of this next week. All right. Len, you have anything? I think I covered.
We got our first box shipment arrived this week, a few days ago. I haven't opened it up yet. I think it's just the grounding bus bar and a few things. I don't know what was ordered. I have to look up to see what the invoice is. But anyway, it's here. It's here. So.
Oh, great.
I'll call Antenna Farm tomorrow and see what the schedule is for anything else that we ordered.
Okay.
They're going to come one or two at a time, I guess.
Great.
You might want to inspect things as they come, just in case there's a problem.
Exactly. I agree with John. Absolutely. Just go and give it a visual inspection, shake the part, make sure it doesn't rattle, right? And go ahead, look at the stuff. Absolutely, Len, inspect it.
Your word is like gold, Len.
But so save the packing list, right? And just make a little check next to the packing list that it's what they say is on the packing list was actually in the box and that it's not damaged.
Take a picture too.
Oh, that's a great idea.
Take a picture when you open the box.
I'll do that.
Okay. Anyway, one step at a time here. Anybody have anything else? We'll get the repeater. The next thing, like I said, is we have to make a definitive decision about the controller and or All-Star and how that all plays into. So if over the week everybody wants to do a little research on that, that could be helpful. And if you see something interesting, just stick it in an email or a message, send it to me, and I can include it on the next go-around here. Thanks again for dropping in, and we'll talk soon.